Hello?
No?
There we go. Can you hear me now? Yeah. Yay. All right, I told him that it needed to go higher, and he said to put it right there. So, all right. So, yeah, like I said, thank you very much for letting me come and talk a little bit about Asterisk at Kamailio World. I think that it's not entirely inappropriate since a lot of you use Kamailio in conjunction with Asterisk. So hopefully there'll be something for you to learn here, or at least to advance your knowledge of how to build better infrastructure using what we do with Asterisk. All right, so who am I? Raise your hand if you've been at a previous Kamailio World. So a lot of people. All right, well, in case you aren't aware of who I am, my name is Matt Fredrickson. I've worked at Digium since about 2001, doing development in lots of different ways. I've worked on Asterisk over the years at different times and in different ways as well. I was the maintainer of libpri, which is the ISDN stack for Asterisk for many years, as well as the Dotty project. I, at one point, realized that we didn't have an SS7 stack for Asterisk, and I thought it'd be really cool if you could connect it directly to the SS7 network. And so, for better or worse, I embarked on an endeavor to write an SS7 stack for Asterisk, right? So all these old dead telephony technologies, that was my world for a very long time. So at some point, they decided to shoot me off into the new world, and they had me work on some WebRTC related initiatives at Digium to build some technologies and other things that we felt would be important for a WebRTC based world. After doing that for a few years, they moved Matt Jordan into the CTO position at Digium, and they asked me to come and lead the Asterisk project. And it sounds really grandiose, but what it really means is I get to work with some really, really smart people, and I try not to get in their way. So, and anyway, that's kind of my job. I've been trying to introduce things from a historical perspective as I do these talks. I want to talk a little bit about Asterisk 1.0. And if you look at all the buzzwords I threw up there, this is a highly editorialized list. But there were pretty much most of the things that you think of in Asterisk were already there, right, in terms of technologies and things like that. There was the first major release was 1.0. It included ISDN as well as analog telephony support. It included H.323 support, which I'm sure everybody's thrilled about at this point, right? Thrilled that it's way back there, right? It included MGCP support. It included AGI, so one of the big programming interfaces that some of you still use to control Asterisk, as well as the SIP channel driver. So it was a fairly complete release if you look at things. 1.6 is a good release because I like to point out wideband audio. So we broke the 8 kilohertz barrier in the Asterisk project, which is really cool. You can start to hear consonant sounds better on the phone. You can hear like better details and things like that. Calls sound better. And then since I wrote the SS7 stack, I had to put a plug in for SS7 support because that's the release I want in there, right? It's a shameless plug. More time passed, right? Asterisk 11, I want to talk a little bit about that because it covers the theme that I'm trying to build here. It was the beginnings of WebRTC support in ChanSIP. That was, there were a lot of other things, but that's what I want to highlight. Asterisk 12, it was the debut of Chan PJ-SIP. So we realized that the SIP stack in Asterisk was at the point where it was difficult to maintain as developers. It was difficult to make changes without introducing new bugs. And so we took a step back and decided that it was time to take a new approach in terms of architecture and try to build something that was better maintainable from all the things we learned from ChanSIP. It also included the ARI, the REST interface for Asterisk, which is very important in moving forward in a web-based world, right? In a web-controlled world. Asterisk 13 included a lot more ARI support and more PJ-SIP support. And Asterisk 14 had asynchronous DNS added to the core, had some more ARI improvements, and also added the ability to publish presence to an external presence arbiter, like a SIP entity like Kamailio World or any of the other ones that are out there. So Asterisk 15, that's what I want to linger a little bit more on because that just very recently happened. It was released in October of this last year. Some of the key technologies that we built for Asterisk 15, one was called Bundle. And that's a technology that's used to multiplex RTP streams, so multiple RTP streams over the same UDP socket sets. And it was really important for browsers. They decided that this was important because the less sockets they had to connect between two endpoints, the more likely you're actually able to connect a call across weird network environments, NATs, and things like that. So in order to reduce that socket count, they tried to, they built some technologies to multiplex audio and video and multiple video streams all over the same UDP socket. We added support for unified plan, which is an STP schema to describe multi-stream video in particular. It doesn't become very important when you're talking about a single audio and a single video stream, but when you start talking about manipulating attributes and describing multiple video streams, it becomes more important. And for those of you that aren't aware, first off, I'm sure most of you are, who is familiar with STP and what it is? Raise your hand if, okay, good. So this is not on, all right. So in terms of the web LAN, there were a number of competing proposals for STP schemas to describe these multi-stream video connections and things like that. And the principal leader opposed from the unified plan was the Plan B approach that Chrome had taken. They'd taken an implementation-first approach. And at the end of the day, the IETF decided that they liked the unified plan approach better. And that was ratified as the schema that would be used. And so Asterisk, since we started a little bit later in terms of doing this, we decided to take a unified plan first approach so that we speak that natively. There were a number of RTP layer improvements. We discovered that for very many years, Asterisk actually, if you're talking about a call with two legs, Asterisk acts as a back-to-back UA. And for those of you that aren't familiar with that technology and what that means is it basically hides one leg from the other. Each leg looks like an independent call. And part of that hiding process was a little bit too well done in that we didn't preserve sequence number gaps and other information related to RTP sequence numbers. So for example, if you had a drop packet that came in on one leg, the other leg had no idea that happened. And actually Asterisk, you could say almost maliciously, hid that fact. For audio, that wasn't really a big deal. But we discovered as we got more into the realm of video that this was a very serious thing. Because if you renumber video packets and you lose the fact that maybe you lost a video packet, the video decoder on the other side can't do anything intelligent with that. And it just breaks the state of the decoder. And so suddenly you've got somebody frozen on your video stream. Or you've got a shard of a body part, like an arm that's not connected to a body that's moving across this. You've all seen it before, right? So in order to better work with video decoders, we realized that this is a big thing that needed to be fixed. We also removed a core limitation in Asterisk that has existed almost since its birth, in that the fundamental assumption of a call in Asterisk includes that there's only one audio stream and only one video stream and no more, and sometimes a text stream, right? And this was a limitation that's existed for a very long time. And so we had to remove that limitation in order to better equip Asterisk for a modern multi-stream video world. And then finally, to connect it all together, we modified Asterisk ConfBridge application, which many of you I'm sure use for conferencing and other things, to be able to act as an SFU. So be able to forward all these video streams among participants. Now, that's not saying we didn't have video support before. We did have a video conferencing experience, but it was, you swapped video senders. So it would be a last talker type situation where you swap video senders. Now you can have everybody see everybody's video stream at the same time, which is really neat. All right, and this is the engineering prototype that we built. Because when you're talking about a bunch of C developers that don't do front-end work, this is the kind of thing that you build. And we were really happy with it, be able to test our technology, but that's kind of what it looked like with wireframe GUI and things like that, and a simple mock-up of how we wanted to make it look and things like that. But we had a lot of fun doing it. We liked it. But if you're a front-end developer, we would love to have some, a little bit of tweaking and improvement and things like that. We're always looking for good help with making it look pretty. All right, so I want to talk about Asterisk 16. So what's up and coming, right? So these are the big categories that I want to cover. WebRTC related video quality improvements, WebRTC related API additions, and improving, well, that's probably better said SFU API additions, and then improving performance in ChamPJ7. So video resilience, why on earth would you want to do that? Well, we already talked about the fact that if you don't do things quite right with video, it looks really funny. You have weird things start to happen in terms of the video decoding context, right? Like you have people, if it gets messed up, you've got weird looking, trippy video with, it looks like you're on drugs or something, and bad things can happen, right? So the fact that just losing a single packet can have significant impact on the quality of the video stream. With audio, it's super forgiving. Like audio decoders are really, really forgiving, but video is a lot more picky. So in Asterisk 15, we took a bit of a sledgehammer approach. If we detected packet loss, we just requested a full new frame, which it kind of gets the job done. So you request from the other side, there's a way of sending an indication to send a new full video frame, and it just resets the decoding context and everything's good, right? Unfortunately, that's somewhat bandwidth intensive. So if the reason why you're dropping packets is because you're saturating your bandwidth, that does not lend itself well to that problem, right? And so there are a bunch of better technologies to help combat those packet loss scenarios. One is called NAC. And this is kind of geeky right here. We're going to go a little bit in the weeds, so you'll have to forgive me. But what NAC is essentially, it's what it sounds like. It's a negative acknowledgement. It's an explicit negative acknowledgement that an RTP receiver can indicate to the other side. So if you're receiving a packet sequence, like the one indicated there, 1, 2, 3, and then suddenly you jump to 6, you realize there's something missing there, right? I missed packet 4 and 5, right? What you can do is, if you're talking to a browser or something else that supports this mechanism, you can send a NAC across the wire indicating that you've missed 4 and 5. And the other side can decide if they're really important packets. And if they're super important ones, it can determine if it would like to retransmit them or take some other kind of corrective action like that. So there are some caveats to this that you have to face. If you are dependent on retransmission-based approaches for corrective action on NAC, this really depends on having low round-trip transit times, right? If you're sending NACs and then it takes like a half second to send a NAC and a half second to receive the response, that's introducing a second of lag, and a second of lag in a video experience is not good, right? In order to correct dynamically, right? So it doesn't work. But for most practical video calls and things like that, the round trip time we found to be it's within a reasonable limit to be able to allow things like that to happen, and it works rather well actually. NACing also causes buffers to get bigger, and I already talked about end-to-end latency, but hopefully the smart people that build endpoint buffers can figure out when to expand and shrink those buffers as needed. But maybe that's me putting a lot of faith into the browser people. But another one is called REMB, and it stands for Receiver Estimated Max Bit Rate. It is an RTCP feedback message as well. Its support for it is negotiated in SDP, so the other end has to explicitly signify that it supports this mechanism. And essentially what it is it's the receiver's calculation, perception of the received bandwidth, right? So if you have a limited, let's say you're on a GPRS connection, and you have a limited leg, and the sender of the video is on I was going to say T1, but that's kind of old school. Let's say on some high-speed LTE connection, right? And he's sending 1.5 meg of video to the receiver. The only thing the receiver will get a fraction of that call, right? Of the packets associated with that call. And so with the REMB, what REMB does is it allows that receiver to indicate to the sender. It says, hey, of the packets they actually receive, this is what my estimated receive bandwidth actually kind of looks like. And if I'm butchering this, Lorenzo, you can come take corrective action on me on this. But that's my understanding of the way the technology works. And so it allows the sender to be able to, instead of sending 1.5 meg worth of video, to scale the transmitter back down so it better fits inside that remote pipe. Right? You can set the transmitter bandwidth down to something that fits better with the receiver's report they can actually receive, right? And so you're less likely to have dropped packets. You're more likely to have a coherent call, right? Another thing that I would like to talk about after video quality things is WebRTC-related API improvements. So just to reiterate, in Asterisk 15, we did a lot of work as far as updating APIs. So there are a lot of internal APIs and things like that were updated to support WebRTC, to support multiple video streams. We built a a front-end interface to support the new SFU code that we wrote. We also added some extensions to the REST interface to be able, so you could build bridges that allow this cool new mixing mode, the SFU mixing mode. So you could build, REST-based applications that allow you to have participants that are in an SFU-like environment where you have lots and lots of video streams going around. And so there were a lot of things that we had to do to change very fundamental things within Asterisk that we had to change, that we wanted to make sure that were right. And we expected there would probably be some more things as people start to deploy and build solutions around the new interfaces, that there probably would be some honing and some tweaking on some of those interfaces. And if you look at this call, I'm going to talk about one specifically. If you look at this picture that I brought up, I don't know if any of you can see it, but there, you can see the people, right? And if you know who they are, I know that's Kevin, and I know that's Malcolm Davenport for those that you know him, and I know that's Kevin's lucky bamboo plant that Josh sent him. But if you look at the text there, it just says remote video, local video, remote video, and there's something up there. It's some audio-only thing, right? There isn't really a name associated with that. And that's something we kind of realized afterwards. We're like, oh, crap. We forgot to add a way to correlate these video elements, so the label that's attached to these video elements, to internal Asterisk information like caller ID or channel information, the channel associated with that. And so we've spent some time trying to build an interface so that the browser can query that information or can determine that information. We hope to have that done by Asterisk 16 as well, so that you can get that internal information and have better metadata about those elements and things like that. So anyway, I think I covered most of this already. Let's talk about performance improvement in ChanPJSIP. There was a really great talk at AstriCon last year about performance differences between ChanSIP and ChanPJSIP. And this is a very interesting topic to us because at some point I can imagine a world where ChanPJSIP is the prevailing SIP stack, right? And we continually want to get to that point where there's no good reason for people to use ChanSIP from a technological perspective. And actually, there were a lot of good things that came from the talk. We found that ChanPJSIP performs significantly better than ChanSIP, like significantly better than ChanSIP in terms of protocol processing, a lot of other certain tests. But there were a few test cases that ChanSIP had better performance than we were happy with. It wasn't on the order of multiple simultaneous calls per, like many simultaneous calls per second or anything like that. It was actually, most of them were in the order of like 1 to 2 calls difference, right? But we don't want anybody to have a technological reason to use ChanSIP. And I don't mean that in a disparaging way. We just want to make sure that ChanPJSIP is a clear victory in terms of moving forward with your technology stacks and things like that in all cases. And so if we're able to fit it, this is one thing that is coming a little bit later, and we were able to work on it little bits over time. But hopefully we're going to be able to address some of those test cases by the time we get to AstriCon. We'll see how things go. All right, so I want to talk a little bit about project background and things like that. Project policy. Asterisk 11 was released in October 2012. That was 6 years ago, a long time ago. Asterisk 12 was in 2013. Asterisk 13 was in 2014. Asterisk 14 was in 2016. Hopefully I said that right. And then we just released Asterisk 15 in 2017. For those of you, I'm sure many of you are familiar with those magical 3 letters, LTS. How many of you love those letters? Yeah, many of you love those letters. Yeah, I mean, I understand why. But all right, so LTS, what does that mean, right? What does that mean to you? I think that it means a lot of things to different people, right? But I'm going to talk about what it means to the Asterisk project. And then you can make your own decisions based on that information. LTS, does it mean that it is more stable, true or false, than a non-LTS? Raise your hand for true. Good, that was a trap. It was a deliberate trap. It is false. It does not necessarily mean that it is more stable than a non-LTS. The only thing it means to Asterisk developers for our policy for LTS is that it receives bug fixes for 4 years instead of 1 year, essentially. So our LTS policy dictates that we keep the branch alive a lot longer. that can be good, right? It does not mean it's more stable, but it can be good if you're trying to adopt a code base that's mostly not changing or not changing too much or not surprising you too much and things like that, right? It does not necessarily mean, though, that it is more stable than a standard release. So let's talk about Asterisk 16. If you notice back on my other slide, Asterisk 15 was surprisingly not an LTS. There was a trend there. 11 was an LTS, 13 was LTS, 15 was not an LTS. I won't say this was the greatest mistake I've made in my life, but people have expressed great frustration with that fact, that it was not an LTS. There was a reason for that. It took a lot of thought and decision to break the convention that we have that typically odd releases of Asterisk are LTS. But we decided with all the core work that we did and the API changes that we expected to happen in the cycle in the next year or so as people start to adopt some of these new technologies that we built, that some of those APIs would evolve and they would change. And we didn't want to stick those APIs as they were in a long-term supported release. We wanted to give it another year of time for people to use things, play with them, and decide what works, what doesn't work, and to be able to bake them. This is nothing about stability. And I would argue that the multi-stream extensions that we did in Asterisk, which is essentially one of the biggest core changes we've done since the inception of the project, have been remarkably stable. There have been people that have told me that, there's an ITSP in particular, and they run virtualized Asterisk for their customers and things like that. And they said that they were running 13 and sometimes 14 in some cases. They moved to 15 for some customers, and they saw that it was more stable than 13 and 14 was. And that's pretty cool, right? You come out with a newer piece of code. This is shortly after 15 was released. And you come out with a new major branch, and your customers or the users of that branch are reporting it's more stable than previous releases. That kind of made us feel good. On the other hand, I believe it is a testament to our testing infrastructure as well. And that's what we get with the investment that we've committed in the last, 7, 8 years in testing infrastructure, automated testing, unit testing, and things like that. That is the benefit that we reap from that infrastructure. It's a ton of work to maintain. It's a ton of work to be able to learn how to contribute tests because it's an entirely new problem space in itself. You got to learn about it. It's separate from what you do when you're just doing development of Asterisk. But we are reaping the benefits of that infrastructure with every release. And I would argue that every new release of Asterisk, every new major release, is the most stable release that we have ever released because of that testing infrastructure. We find bugs before customers and users hit it, and we're able to correct things as it gets more and more comprehensive, more rapidly and more readily. So Asterisk 16 will be an LTS. I was expecting applause or something. All right, well, anyway, there's a couple people in the world that are excited that Asterisk 16 will be an LTS. So anyway, that's it. So just as a reminder, Asterisk 11, how many of you are running Asterisk 11? I don't know if I want to know the answer to this question. Never mind. All right. So yeah, Asterisk 11 went end of life in October. So it's a good time to get off that branch. It does not receive security updates anymore. So if you're running it on a publicly connected box, that's not a great idea, right? You probably want to get off that branch. Yeah. If you are running an older version of Asterisk, and many of you are running, I will not publicly shame you, but I would advise you to move forward. It's a good thing. There's a lot of good things in newer versions of it. So another thing that I would advise as well is to keep track of what's happening in non-LTS branches. For those of you that typically stick to LTS branches, keep track of what's going on in those branches. Because if you don't adopt until a new LTS branch is released, you could be surprised. There could be things that have changed that you could have fixed. Like in terms of somebody changed some critical argument that you care about in a dial plan application or something like that. That could have been fixed before it ever went into a release a long time ago, right? If you keep on top of those things and report that back to us. So I would advise you to try to keep on top of what's happening with releases. As a last note, I don't want to shamelessly plug too much, but Astricon, if you use Asterisk in your infrastructure, is coming up in October, and it's the 9th through 11th. If you use Asterisk, this is the best place to go learn how to use it better, to learn how you can better utilize it in your infrastructure and learn how others are using it. Best practices, deployment, new things that it does, anything that is related to Asterisk, this is an excellent opportunity to go and learn about more. And if you use that discount code Community 2018, you can get a 20% discount on admission. And of course, we're looking for speakers. So any of you would like to talk about your usage of Asterisk or something about it, you're welcome. And obviously, if you speak, you don't have to pay for a ticket. So that's another added advantage. Thank you guys very much for your time and attention, for allowing me to come and visit you all at this Kamailio conference and talk a little bit about Asterisk. Does anybody have any questions? Tori, I knew you'd have a question.
Here is the mic. Please tell us. Community-driven mic.
I have a question with regards to the RTCP NAC.
OK.
One of my as is a feedback event, I was understanding that what makes it different from a normal RTCP event is you can send it immediately. You don't have to wait for the periodic stuff. But on your slide, you were saying that you could have a slow round trip time, implying that you actually are only sending it whenever an RTCP port's normally being generated?
That was not the implication.
Okay.
Actually, I'm fairly certain you can send it on demand.
Okay.
But I've got my guy who did it back there, or help with it significantly, who can back me up on that. Yeah, I believe it does require sending a report with it, at least the way that it's deployed. But Josh, do you want to talk about that?
Sure, why not? Talking is good. You can send it anytime on demand. It is a compound packet, so you do have to send another report at the front, an SR or an RR, but you can send it whenever. What Matt was referring to was the actual latency of getting the RTCP packet from one side to the other, having the other side, be it the browser, actually handle it, and then sending the retransmitted packet back.
Yeah. Yeah, so just network and remote endpoint related latencies that may come up. Thanks, Josh. I appreciate that.
Here, one question.
Hi. We got during the Kamailio word that now natively Asterisk is supporting AMR wideband codecs. You confirm it?
That sounds wonderful. It does not sound like the branch of Asterisk that I released, but there might be something on GitHub somewhere that does that.
And
I cannot confirm or deny that because I work for a US-based company that honors US-based patent law. So, there are certain restrictions that we take upon ourselves because of potential liability and things like that. So there might or might not be a version on GitHub that supports it, but I'm not sure.
yeah, another question about the RTP multiplex in the bundle that you were mentioning. Is it also supported for the SIP trunk? Sorry.
Pardon me, for the SIP what?
Yes, SIP trunk. If I have a 2 Asterisk, I wanted to use a SIP trunk to
actually,
save bandwidth.
I think that would work. What do you think, Josh?
That's a question. Are you referring to multiple individual calls sharing a single RTP session with streams over that, or multiple streams within a single call?
No, it's a multiple calls. I mean to save bandwidth, actually.
Bundle is not used for that. It's strictly used for within the same RTP session, so within the same call. Bundle is actually a defined specification. That's a question. I don't know, with the way that bundle is written as a specification, whether you could technically use it for that purpose or not.
I don't think it would save you in bandwidth, though, because
correct,
there's no like reduced layering. There's no reduced bandwidth associated with it. It's just, it's the most ultimate, let's hack it, let's hack them both on the same socket.
Yes, it just saves ports, basically. Yeah. Packets are still individually sent over the port. They aren't combined to save on the IP header.
Yeah.
You save the IP header for every packet. You can be able to bundle together.
Yes, I believe there's actually a different specification for doing that, but I can't remember the RFC for it, as there are many RFCs in the world these days.
Okay. Thank you, Matt, Josh, of course, and don't forget.